Okay, this time I have this question, subtree of another tree. So again, it is an easy level question. We have given two things, root and subroot. So we have to check, is this subroot tree exist in this root tree? So we have to just, our task is simple. So see, we have done this question, same question like this, that was same tree. Inside that question, we were checking two things. We were given like this. Okay, so let me make a tree. Suppose this is, we were given like this. Okay, why can't I select this ellipsis? Okay, so I'm copying this, and we were given this three things. Okay, like this. Suppose this is our first tree. One, two, and three. So I've made a tree for you, and our second tree is also same. Okay, our second tree is same. Okay, perfect. So this is our second tree. So we were given that time P and Q. This is P, and this is Q. So we had to check in that function, in that question, we had to check, are these functions equal? So if they are, these trees equal? So yes, these trees are equal. So for that we have to return true. If they are not equal, then we have to return false. Given false, yes, we have to give false. So okay, so we had to give false if they are not true. So we will do this. So we will make same tree function here as well. So first I'm making that function. Function, okay, function, uh, same tree. Okay, same tree. Inside this I will pass P and Q. Yes, I'll pass P and Q, and then I will do what? I will check uh, if my uh, I will see, I will use a bottom up approach here. My P and Q are equal right now, value of P and Q are equal. So if P dot val not equal to Q dot val, Q dot val, not, it is one equal to, not equal to, yes, not equal to Q dot val, I have to just return false from that. Yes, perfect. So I have to give false from that. Otherwise I have to do what? Otherwise, go to leftmost and go to rightmost. So go to left. Let left is equals to same tree. Yes. P dot comma uh, Q dot right. Yes. Yes. And just like that, we will go Q dot left, not right. Q dot left only. We will go to leftmost of both the trees. If these both are equal, then we will go to left of both the trees. Then we will check these two values. If these two are equal, we will go to left of both the trees. That is null. Okay, that is null. That's a best explanation, I think. So this is right. Yes, and like this only, we will go to right only. RAGHT and again RAGHT. So we will go to leftmost. If suppose anytime, if my not of P, okay, not of P and not of Q. So this not means if both are null, then I just need to return true from that. Else, if one of them is null, if P is null or uh, again, if P is null or Q is null, if one of them is null, I have to just return false from that. Perfect. So at last I have to return left and right. So see, this will return me if they are null. This will also be null. This will return me true, and this will also return me true. Yes, if left is a, if we have done left, so then it will call for this null. That will also give me true. I will return its and so its and will be true. Then this left is done. Then it will call with right. Right will also give me like same, and then we will call this function for true. Okay, that is it. So now I'll make this function subtree. Inside that, I will call that same tree with root comma subroot. If uh, same tree of root, okay. root comma subroot is not valid, suppose is false, suppose it is false, then I will do what, I will call this is subtree function again. Okay, I'll call this function is subtree with root dot left and subroot. Yes, I'll call this function with root dot left comma subroot, and I'll name it let left is equals to, yes, and I'll do the same for right. Let me type fast for this. Is a subtree, yes, root dot right comma uh, subroot, yes, subroot. Yes. So we will call this function for left and right for subtree. Okay, if it is not valid, and suppose if root is not valid, there may be a chance where root is not valid. If not of root, then return false. So suppose this left will go to the leftmost of this, and then it will call with null. So at that time, this will return false to us, and root dot right will also return false to us that time. Then I will return from it. I will return what? Okay, return left or right. Yes, uh, yes. Perfect. I will return this. And suppose I'm returning this root dot left and root dot right. Uh, See, when we will go to, okay, I don't have that picture yet. Yeah. Okay, why can't I copy that image? Yes, this is our image. We will go to leftmost. Okay, we will go to leftmost, and this will return us what? Root dot subroot and subroot will be false here. So, but before going here, we will go from top to bottom. Okay, return true if this is true. So first time this will be called for this only. First time this function will be called for 3 and 4. It will give us false. So if it is if it is giving us false, we will call it for left first, left and this. So this will return us true. So then now this function will not be called for this left again. This function will not be called for this left again. This will call for with this right. This will give us false. This right line give us false. So then this will be called for right and 4, 5 and 4. This will give us false. Yes. Again this will be called for 2 and null. That will return our function. Yes. If root is false, then return. Yes. So that is our function. And root dot right and subroot. Yes. Now root. Now we do not have any root. So return false. This will return as false when this will be called with 5 and 4. So okay, perfect. So if I run this, let me see. If I run this, this will be accepted, and if I submit this, this will be submitted. So this is a one approach to this. But what if someone says you that you have to do it in O of n? Right now we are doing O of n square. Why? See why we are doing O of n square. We are checking with each node. We are doing n times iteration. Okay, inside that we are checking each one with this, so that is also taking n iterations. So that is why it is kind of n o of n square. Yes, so m into n, or you can say. So we will not use this approach. Then what we will use, we will make a hash out of it. How can we make a hash? We will do pre-order traversal here. Okay, pre-order traversal is root right, root left right. Yes, root left right. Yes. So root left right. If I do pre-order traversal of this, root is 3, 3 left right. Then we will go to left of 3. So 1 left right. Okay. So 1. Then 1 of left is null. Null right. Right is what? Again null. Yes. And see, its a pre-order traversal is this. So okay, I'm doing it wrong. Why? See, if I do pre-order traversal of this, if I do pre-order traversal of this, this will give me root, okay, left, right, root, left, right. But here also root, left, right, then root, left, right. But left is null, so we will not push it. Then see, this 4 is done, left is also done. then right, then right comes 2. Now root left right is done, this root 3 is also done, now 5 is the last. So this is the pre-order traversal of that. And if I do pre-order traversal of subroot, that will be 412. So now you would be saying that we can check if this array includes this. See, this array is 412. If that root array includes this, then that means that is a solution. But no, that is not a solution, because suppose if you have this type of example, if you do its pre-order traversal, then you will have this 0 as well inside that. So after that you will have this, after 2 you will have 0, like this. See, root left right, so 3 4 uh 3, then we will go to left, then 4, okay, then we'll go to left, 3 4 1, and then 205, yes, 205. So that is not our solution. What we will do, we will after each node, not this, after each we will use a delimiter. How? We will mark like this, each node like this. Okay, after each node we will push something like this. Yes, and we will also mark null. Okay, with hash, we will mark null with hash. Suppose after one I have a null. Suppose after one I have a null, so I will do what? See, after this one we have null node, so root left is like this, hash, and right is also like this, hash hash. So see, I'm removing all these commas. Now we don't need these commas. Okay, root left right and root left right. And each time I will create a. So see, now if you create something like this, after 5 and 2 you also have to, you need to do this thing, hash comma hash. So after 2 also this will be there, because after 2 both the nodes are null, and after 5 also both the nodes are null, so this will be like this. And if you check this 4 to 1 string, so after 4 also you need to put these. I'm making that comma delimited array. After 1 we have two null nodes. Okay, after 1 we have two null nodes. I'm doing that. After 1 we have two null nodes, and after 2 also we have two null nodes. Yes, perfect. So this is our see, now if you check this, see, okay, that is our task and we have done it. So we'll do what? Okay, here I have to push a dash as well. Now if you compare these two, see, these both are equal. Their hash string is also equal. This is, we have generated a hash string, and if you compare both of them, this is the hash string of subroot. This is the hash string of subroot, and this is the hash string of root. Okay, if you compare them, hash string of root includes subroot. If you generate hash string of this, then you will get after 2 0 as well. So after 2 hash will not be there, so then that will not be your answer. So we have to do something like this. So now how can I generate this subroot? And let me write code for that. So for generating subroot, I am creating a function. Okay, not sun, function. uh, okay, function, what function, what shall I name that function? Serialize. uh, okay, serialize. And I will pass what, I will pass current to it. Okay, and I will create a hash string here. Let hash is equals to empty right now, or let me create that hash there only, here only. Okay, I'm creating my hash here, and now I will also create again one more function. Okay, function traverse. Right now I'm doing pre-order traversal, so current is required here. Now we will use recursion. We will do what? We will hash plus hash plus is equals to what? We will see, if you do pre-order traversal of this, first time you have to create hash of this. So hash plus is equals to current dot val plus this thing, and before also that, plus this thing. So if I do this plus this, so current dot val plus this and current dot val plus this. Okay, then we will call the same function traverse for current dot left. Okay, and then we will call traverse for current dot right. Perfect. Then we'll call this function for current dot right. And once we reach to null, if current is not valid, if null of current, yes, suppose we are calling it for null, then I will what to do, then just return. But before returning you have to do one more thing. Hash plus is equals to uh, null. Okay, null hash null. Perfect. So this will be my string hash string function, and now I will call serialize function. And see, after this function I will call traverse with current, and I will return hash to its parent. The serialize function will be called uh, let my uh, root root str. I'm calling it root str, and that will be my sub str. So root str will be what? I will call this serialize function with root. Yes, root, and let sub str is equals to serial rialized with again subroot. Yes, I'll call this function with subroot. Now see, if you call this with root and subroot, you will have something inside them. So console.log, do you want to see what will be how are these strings look? So right now I was making them str. Now I'll show you inside that TL draw panel. I was showing you by dry running how they will look, but now this system will show you how they look. Sub root. If I do console.log, see, this will not give me answer, but I just want to show you how a strings will look. So okay, this is our okay subroot. Oh, I have written subroot there. Sub str. Now this will give me right. See, our root is this, root string is this, and our substring is this, subroot string is this. And see, this is included in this. Yes, that's what I was showing to you. See, this is same as we created here. Dash 4 double dash 1 dash 4 double dash 1 double dash hash and double dash hash. Okay, that's same like this only. So we created this only. That is same. And if you see test case number 2, test result of test case number 2, there if you see this is our this string substring, yes, and this is our root string, so this will not include. See, if you see this, 0 is there, so they will not be a substring of each other. This substring is will not be a root of root string. This sub str will not be a substring of root str. Yes, so I just now have to return root str dot includes is a function in Java. So see, if suppose if interviewer wants to want you to write not use a predefined function. Suppose if he say that you cannot use a predefined function, then what will you do? Then you can use that KMP algo. Yes, KMP algorithm. That will help you to write to check that they are substring of each other or not in O of n. Okay, again I'm telling you O of n. Otherwise, doing it in O of n squared, we have lots of methods. Sliding window is also there. But if you want to do it in O of n, then you have to use KMP algorithm or Robin Karp. But I would suggest you to use KMP also. KMP. So okay, root.str includes sub str. Perfect. If I submit it, this will be accepted, and this will give me in O of n. Okay. Includes is a function, I think. I cannot remember that function. Includes or include, I don't know. INCLUD. Okay, so spelling was also correct. And if I submit this, this is a much better solution than that previous approach. This was in O of n square. Now we are doing it in O of n. Yes. See, it is submitted, and if I analyze its complexity, it is what? O of n plus n means kind of O of n. That time was O of n into m. That is a very bad complexity. And see, this one line is doing that function of KMP algo. I can make that KMP algorithm while by using two while loop, but that will take time and this video will go long. So that's why. So that was my solution. Thank you so much for this.